Welcome, pre-cal students, to the homework help video, page 655, 1 through 77, every other odd. Let's go ahead and get started. Let's take a look at number 1 here. The directions say to, let me turn over my book here to where we're supposed to be. Hold on one second. The directions say to find the exact value, and so here we go. Let's go ahead and take a look at these. Here we're going to find the exact value of the cosine of pi over 4 plus 30. Now, okay, here we go. We're going to use our sum and difference formulas. Okay, so with that in mind, whenever we have the cosine of two angles that are being added, we can take cosine minus sine. So we're going to call this u, we're going to call this v, and here we go. Cosine of u, cosine of v, minus sine of u, sine of v. Not too bad, okay? So we have the cosine of pi over 4, cosine of pi over 3, sine of pi over 4, and sine of pi over 3. And those are angles that we do know. So let's pull this up here real quick and slide it down a little, and here we go. Okay, students, let's see what we got here. We got the cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. And the cosine of pi over 3 would be 1/2. Minus the sine of pi over 4 would be square root of 2 over 2. And the sine of pi over 3 would be square root of 3 over 2. And there we go. Let's go ahead and slide this out of the way real quick here. And let's simplify, and we should be done. So here we go. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. Minus square root of 2 times square root of 3 would be square root of 6 over 4. And now we'll combine these two fractions, and we should come up with square root of 2 minus square root of 6 all over 4. Now, students, hopefully you remember from Algebra 2, you cannot combine radical square roots unless the inside numbers are the same. In other words, if you had 2 square root of 5 plus 4 square root of 5, then you could go ahead and combine those, and you would put 6 square root of 5. Okay, the insides would stay the same. It's almost like, in fact, it's exactly like adding like terms. If you had 2x plus 4x, you would put 6x, and it's the exact same thing. Okay, all right. So here's your answer right here. Here's your answer right here, okay? And there's nothing you can do. You cannot reduce that because this is an inside number, this is an inside number, this is an outside number. It's not under a radical. So there is no reducing you can do. Okay, moving on to number 5. All right, here we go. Cosine of 120 plus 45. Well, same thing again as the last problem. It's identical, actually, so here we go. Let's take a look at it real quick. I better check the answer key to make sure we did this correctly. I always want to check the answers. Yes, we got that correct. Okay, moving on to number 5. It'll be the exact same thing again, which is cosine minus sine. So here we go. Cosine of 120, cosine of 45, minus sine of 120, sine of 45. Now, you might say, Mr. Earhart, we're in trouble on this one because we don't know what 120 degrees is. Nowhere on our table do we see 120 degrees. And you're right, you don't. But remember, if I ask you to find the trig function of 120 degrees, that's the exact same thing as drawing your angle. And the reference angle for that would be 60. And so really, when you're finding the cosine of 120, it's the same thing as finding the cosine of 60, as long as you remember that cosine here is negative and sine is positive, okay? So keep that in mind. So when we go to find the cosine of 120, we're going to use the cosine of 60. But I got to remember the cosine of 60 in quadrant 2 is negative. So I'm going to put a little negative sign here so I don't forget that, okay? Times. And actually, I'm going to go ahead and do this. I'm going to go ahead and put the cosine of 120 as the cosine of 60. So cosine of 60 is 1/2. I'm going to put a negative 1/2, okay? And then cosine of 45 will be square root of 2 over 2 minus sine of 120 would be the sine of 60, and sine is positive, so sine of 60 is square root of 3 over 2. And the sine of 45 would be square root of 2 over 2. So square root of 2 over 2. And here we go very quickly. All right, let's get this out of the way here. And we have, let's see here, negative times a positive is negative. Square root of 2 over 4 minus square root of 6 over 4. We do have a common denominator, so we'll go ahead and put these together. And we would end up with negative square root of 2 minus square root of 6 all over 4. I'm going to quickly check my answer in the book here to make sure we've done this correctly, and we have. Yes, that is correct, okay? All right, moving on to number 9. Number 9. Okay, now the direction should say, I think we're going to go backwards now. Let me take a look here and see. The directions say, find the exact values of the sine, cosine, and tangent. We're going to do just tangent, of course. And so what they're showing you here is that 195, they're trying to show you here that if you take the tangent of 195, that's the exact same thing as taking the tangent of 225 minus 30, okay? Now, in our table, we don't know the tangent of 225, but we can draw a reference angle for 225, and when we do, we come up with this. 45 degrees, and tangent here is positive. So when I take the tangent of 225, it's really the exact same thing as taking the tangent of 45. As long as sorry guys, hold on. As long as I remember that tangent here is positive, okay? So tangent of 225 is the same thing as the tangent of 45. As long as I remember it's positive, okay? So here we go. Tangent of 225 minus tangent of 30 would be the same thing as, now let's use our trig identities, okay? We know that we have tangent of u plus tangent of v. So it would be the tangent of, now remember, tangent of 225 is the exact same thing as the tangent of 45, okay? Because tangent in this quadrant is positive, okay? Plus the tangent of v, so plus the tangent of 30. And I think I made a little mistake there. I apologize, guys. It should be minus, my fault, because you're taking two angles here and you're subtracting them, okay? So tangent of 45 minus the tangent of 30 all over, let's see here, 1 plus tangent of u, 1 plus tangent of course, u is 225, we're going to use 45, times the tangent of 30, which is v, okay? So with that in mind, let's quickly fill in these trig values, then we'll be good to go. So here we go. Okay, tangent of, let's see, 45 would be tangent of 45 is 1. So 1 minus tangent of 30 would be tangent of square root of 3 over 3. All over 1 plus tangent of 45 is 1 times tangent of 30 square root of 3 over 3. Okay? And so here we go. Let's go and get rid of this. And let's get to work on simplifying. So here we go. 1 here is the same thing as 3 over 3. So in my numerator, I have 3 minus square root of 3 all over 3. And then down here in my denominator, of course, 1 times square root of 3 over 3 is just square root of 3 over 3. So I have 1 plus square root of 3 over 3. Of course, 1 is 3 over 3. So I really have 3 plus square root of 3 over 3. Now, if you take your top fraction and you divide it by the bottom fraction, you're really going to just flip the bottom fraction and multiply. So you really have times 3 over 3 plus square root of 3. Okay, so I flip the bottom fraction, multiply it times the top. Your 3's would cancel, and you're left with 3 minus square root of 3 over 3 plus square root of 3. Now, I'm going to look in the back of the book. I don't think that answer is acceptable. I'm pretty sure it's not. Let me see here. We're on number what? 9, tangent. And they are, let's see here. No, it is not acceptable. So what they want you to do is this. They want you to rationalize the denominator by multiplying the top and the bottom by the conjugate. So if your denominator is 3 plus square root of 3, you're going to put 3 minus square root of 3. 3 minus square root of 3 minus square root of 3. Now, here's where I got that from. In your denominator, you always take the middle sign here and you change it. And so because this is a positive right here, we're going to put a negative over here. Okay, so we need to move this and get some room to work with. So here we go. And here we go. 3 times 3 is 9. 3 times negative square root of 3 is negative 3 square root of 3. Negative square root of 3 times 3 is negative 3 square root of 3. And negative times a negative is positive. Square root of 3 times square root of 3 is 3. So your entire numerator becomes 9 plus 3 is 12 minus 6 square root of 3. I put these two terms together and I put those two terms together. Now in the bottom here, in your denominator, 3 times 3 is 9. 3 times square root of 3 is negative 3 square root of 3. Square root of 3 times 3 is positive 3 square root of 3. You can see these are going to cancel out. And then positive times negative is negative. Square root of 3 times 3 is 3. These cancel out. 9 minus 3 is 6. Now, this is an outside number. This is an outside number. This is an outside number. In other words, they're not under a radical, so you can reduce. You can reduce this and divide everything by 6. Okay, so 6 goes into 6, 6 goes into 6, 6 goes into 12, 2. So your final answer is 2 minus square root of 3. I'm checking the answer book now, and let's see if we got that correct. It looks like we totally missed it. I'm kidding. It's exactly right. So we're good. Okay, moving on to number. And by the way, that's why in numbers 9, 13, and 17, and 21, I only made you do just tangent or just sine or just cosine because they're so long. Okay, so moving on to number 13, I'm pretty sure I told you to do sine. Okay, so they want you to take the sine of 17 pi over 12, which is the same thing as the sine of 9 pi over 4 minus 5 pi over 6. Now we're doing pretty good, but hold on a second. Look at this. The only problem I have is on my table here, I don't have 9 pi over 4 or 5 pi over 6. So I'll have to find some reference angles here. Okay, so let's do that real quick. Here we go. Okay, 9 pi over 4 is 2 and 1/4 pi. Okay, 9 over 4 is 2 and 1/4 pi. So that means I go 2 and then a fourth. Well, a fourth is 45 degrees. So that's pretty easy. I mean, 45, if I take the sine of 9 pi over 4, that's the exact same thing as taking the sine of 45. And remember, everything in the first quadrant is positive, so I'm just going to go ahead and change this to 45 degrees. Okay, that's pretty easy. Now, 5 pi over 6, that's going to be 150 degrees. And notice we go here, and if we go 150, we're left with 30, okay? Now be careful on this one because sine is negative and cosine is, sine is positive and cosine is negative, so be really careful here. We're going to use 30 degrees, but watch your signs, okay? Be very careful with your positives and your negatives. Okay, so here we go. Okay, whenever you're subtracting two angles, your trig identity state that you can go sine, cosine, minus cosine, sine. So we have sine 45, cosine of 30. Remember, it's going to be negative. Put a little negative sign here so you don't forget that, okay? Sine, cosine, minus cosine, sine. So minus cosine of 45, sine of 30. And here we go. Let's pull this back up here. And here we go, okay? The sine of 45 is square root of 2 over 2 times cosine of 30 is square root of 3 over 2. So you got to make it negative, so negative square root of 3 over 2 minus cosine of 45 is square root of 2 over 2 times sine of 30 is 1/2, okay? And by the way, we did not make sine negative because the second quadrant sine is positive. Okay, so we're good there. All right, let's get rid of our stuff here if we can. And let's finish this quickly. Positive times a negative is negative square root of 6 over 4 minus square root of 2 over 4. We've had this before, I believe, so it's negative square root of 6 minus square root of 2 over 4. Let me check the answer key very quickly to make sure we're right on this, and we will continue on. Number 13, sine. Let's see here. Yes, they're writing their answer a little different form, but we're totally accurate on this. We're totally good, okay? So, moving on. Here we go. Number 17, we're doing this cosine, okay, the cosine. So, cosine of negative 165, okay? Now, on this one, I don't think they give you, let me take a look here in the directions. Number 17, yes, they don't help you this time. They don't show you what two angles you're adding or subtracting. Okay, so here's what I'm going to come up with. I'm going to do this. Okay, I'm going to say that, let me think this through for a second here. Okay, this should work here, students. Okay, watch this. I'm going to use the cosine of negative, let's see, I got to be really careful here doing this because of having subtracting angles and adding angles. Let me think about this for a second. Okay, students, I'm back here, and I've been looking this over. I think the easiest way to do this, students, would be to do this. It's okay to use negative 165, and the back of the book does it differently than how I'm going to do it. But I'll be honest with you, I think using a negative angle here is going to be really tough to do. So here's my suggestion to you. Remember, negative 165 would be the exact same thing as positive 195. Okay? Let's go over that again, okay? The negative 165 degrees is the exact same thing as positive 195 because 165 plus 195 would be 360. I would recommend that you use positive angles here and not negatives because it gets really, really messy when you start trying to use negative angles here. That's just my suggestion to you, okay? So you do it, you do what you want to, but that's my suggestion to you. So with that in mind, I would do this. I would take the cosine of 195. Now that's okay because that breaks down very nicely into this. 135 plus 60, okay? Now that's okay. We know both of those, okay? And here's how we know that for 135, I go 135, the reference angle for 135 is 45, okay? As long as I remember that sine is positive and cosine is negative when I use 45. Okay, now 60, of course, is just 60, so we're okay there. All right, so here we go. We're taking cosine plus cosine, which is cosine cosine minus sine sine, so it would be cosine 135. Actually, I'm going to use 45. As long as I remember, that's going to give me out a negative, okay? Cosine 45, cosine of 60, minus sine of 45, sine of 60. And there we go. Let's do this very quickly here. Pull this up here, and here we go. All right, let's see what we have here. We have okay, cosine of 45 would be cosine of 45 is square root of 2 over 2. Cosine of 60 would be 1/2. Sine of 45 would be square root of 2 over 2. Sine of 60 is square root of 3 over 2. And we get negative square root of 2 over 4 minus square root of 6 over 2. We're getting the same answer over and over. Negative square root of 2 minus square root of 6 all over. This would be a 4 right here. All over 4. Let me check the back of the book real quick for number 17 here. And we are getting, let's see here. Should be the exact same thing, which is you want to have square root of 2 minus square root of 3 over 2. Yep, exact same answer. Okay, moving on to number 21. Number 21 is going to be tangent. And I would recommend that you definitely change 13 pi over 12 2 degrees. It'd be a lot easier trying to figure out the angles that you're going to add or subtract. Okay, so here we go. Let's see what we can do here. Okay, students, when you convert this over to degrees, you get negative 195. So we're going to take the tangent of negative 195. And of course, negative 195, like this, would be the exact same thing as what we just looked at before. I think it's 1 positive 165, I believe. Is that right? Let's see, 165. Yes. So negative 195 is the same thing as positive 165. So I'm going to use positive 165. Okay. So tangent of negative 195 would be the same thing as the tangent of 165. All right. Now let's see what we can do here. How about 135 plus 30 would work nicely. So tangent of 135 plus 30 would be 165. Okay, so having that in mind, the reference angle for 135 would be 45. If you drew 135 degrees, you'd be left over with 45 degrees, and tangent is negative, so we can use 45 degrees here as long as we remember the tangent of that is negative. Okay, and so here we go. Let's see what we have here. Tangent, when you're adding two angles, would be tangent plus tangent. So we have tangent of 45 plus the tangent of 30 all over 1 minus tangent tangent. So 1 minus tangent of 45, tangent of 30. Remember, tangent of 45 is negative, okay? All right. Let's pull up our chart here real quick. And here we go. Tangent of 45 is 1, so I'm going to put a negative 1. Plus tangent of 30 would be square root of 3 over 3. All over 1 minus, now tangent of 45 would be negative 1. And then tangent of 30 would be square root of 3 over 3. Okay, there we go. And let's quickly simplify. Here we go. For negative 1 right here, I'm going to put negative 3 over 3, so that'll work just fine. And that did not work just fine, so hold on 1 second. It's freezing up on me. All right, here we go. Okay. Is it all done? All right, there we go. All right. So negative 3 over 3. And down here, let's see, we have a negative times a negative is a positive times a positive is positive. So we really have 1 plus square root of 3 over 3. So I'm going to call that 3 over 3 for this right here. So 3 over 3. Okay, so here we go. We have negative 3 plus square root of 3 all over 3. That's all over 3 plus square root of 3 all over 3. Okay, so we're going to take the fraction. We're going to flip it and multiply. So we have 3 over 3 plus square root of 3. These cancel. And we're left with negative 3 plus square root of 3 all over 3 plus square root of 3. Okay, there we go. And let's quickly simplify this and we'll be finished, okay? Take your middle sign here and change it to a negative. So we're going to multiply the top and the bottom by 3. Minus square root of 3, 3 minus square root of 3, and you'll come up with 3 times 3 is a negative 9. That'd be a positive 3 square root of 3. Positive 3 square root of 3. Positive times negative is negative. Square root of 3 times square root of 3 is 3. So we end up with negative 12 plus 6 square root of 3. Alright? Now the denominator, if you do all your multiplication, you'll get positive 9 minus 3, which is 6. So we can reduce this outside number and this outside number and this outside number by 6. So this is a 1, this is a 1, this is a negative 2. So your final answer should be negative 2 plus square root of 3. Let me look at the answer book real quick and make sure we got this right. And then we're going to move on. Okay, number 21. We did tangent, and yes, that is correct. Okay, moving on to number 25. Now, I think what they want us to do here, let me look at the directions. This should be a little easier. Now we're going to go backwards. We're going to write it, the expression as sine, cosine, or tangent, okay, of an angle. This will be really easy, much easier than what we've been doing. So here we go. Notice I have tangent minus tangent up top, and then down here 1 plus tangent. Okay, now if you look in your trig identities, your sum and difference trig identities, you're going to see that ends up being, well, this is your u, and this is your v. This is your u, this is your v. And so what you end up with whenever you have tangent minus tangent in the top of the fraction, and the bottom here is 1 plus tangent, tangent. That's the same thing as taking tangent. Look at your trig identity sheets and you'll see this. It's the same thing as taking tangent u minus v, which is tangent 325 minus 86, which would be the same as tangent of 239. Well, that's easy, and we could move on. Okay, not too bad. All right, number 29, same thing, I believe. Let's see here. Notice we have, well, same thing. We have plus. We have two tangents. It'd be a little different. We have a plus sign here and a minus sign down here. So if you'll notice, that would be the same thing as, if you'll look at your trig identity, you'll see it's tangent of u plus v. Okay. So u is what? 2x, and v is x. So for u we'll put 2x, for v we'll put x. And so the answer would be tangent of 3x, okay? Pretty simple. Moving on to number 33. Same thing again, I believe. Let's take a look here. Yes. Let's make sure the direction, let me check the directions real quick. Number 33. Okay, they want us to find the exact value very quickly. So, to be honest with you, I'm going to change all of these 2 degrees very quickly. I think it'd be a lot easier. Let's see, this would be 15 degrees, sine of 15 degrees. This would be 45 degrees, 15 degrees, and 45. Now, having done that, here we go. Notice we have sine, cosine, plus cosine, sine. So if you look in your trig identities, whenever you have sine, cosine, plus cosine, sine, that's going to be sine u plus v. Okay, so sine u plus v, and of course u is 15 degrees, and v is 45 degrees, and 15 plus 45 is 60, so we have the sine of 60, okay? And the sine of 60 is square root of 3 over 2, okay? So we would have square root of 3 over 2 for an answer, okay? All right, moving on to number 37, okay? Now on numbers 37 and 41, they want us to find the exact value of the trig function, and they've given us the sine of u is 5/13. So they've given that to us, okay? And the cosine of u is -3/5. Now, they were very nice to tell us that we're in quadrant 2. You'll see that in the directions. But they really did not have to tell us that. On a test or a quiz, I would expect you to see that right away, because the sine of u is positive and the cosine of u is negative. And anytime you have a sine giving you a positive and cosine giving you a negative, that's got to be a second quadrant, okay? So we are dealing with second quadrant. Okay, keep that in mind. But here we go. Sine of u plus v would be sine cosine plus cosine sine. Sine cosine plus cosine sine. Okay, so here we go. Sine of u would be 5/13 times cosine of v. Now let's hold on one second here real quick. Okay, students, I wanted to check something really quick. I made a mistake and I apologize to you. Let's kind of start this over real quick if we could. First of all, in the book it says cosine of v is -3/5. Okay, first of all. And secondly, they do have to tell you you're in quadrant 2. And the reason they have to tell you that is you have two different angles. You have sine of u and cosine of v, okay? And so because of that, you definitely have to know what quadrant you're in. So it's my fault. Also, they don't tell us what the cosine of u is, so we have to find that very quickly. Okay, so here's u, and we know here's angle u, and we have opposite over hypotenuse, and that would be 169 minus 25 would be 144, so this would be 12 right here, okay? And then for v, we come over here, we have cosine of v, here's v right here, adjacent over hypotenuse, and using Pythagorean's theorem, this would be 4. Okay, that's a big help to us. Now we can continue on, okay? All right, here we go. So we have sine of two angles being added. That's sine, cosine, cosine, sine. So we have sine, cosine, plus cosine, sine. So the sine of u they've given to us 5/13. The cosine of v they've given to us -3/5. However, the cosine of u they've not given to us, so here it is, adjacent over hypotenuse, so it'd be negative. Cosine is negative in the second quadrant, -12/13. And then sine of v is positive, it'd be opposite over hypotenuse, so 4/5. And here we go, we get 15 over 45, -15/45, plus negative 48 over 45, so negative, and we're going to add two negatives, we would get -63 over 45, which makes the whole fraction negative. 9 goes into both of those. I'm getting -7/5. I hope we did that right. I'm looking here carefully. I have this feeling we made a mistake here on 37, and it looks like we did make a mistake, because 13 times 5 is 65. This would be 65. This would be 65, and you cannot reduce it, so not too big of a mistake. So there's your answer right here, -63 over 65. Okay, all right, moving on, number 41. Number 41, let's go back a page. Let's cut and paste this real quick, or drag it. Actually, let's drag this whole thing over to the next page so we can use all this information. Okay, there we go. Okay, so we have tangent of u plus v. Now your trig identities say that would be tangent of u plus tangent of v all over 1 minus tangent u tangent v. Okay, there we go. So for tangent of u, here's angle u right here. That'd be opposite over adjacent. So 5/12 plus tangent of v. Here's v over here. That'd be opposite over adjacent. So 4/3. So down here we'd have 1 minus 5/12 times 4/3. Okay, let's go across. Let's go across this way. To get a common denominator, it'd be 16 over 12. So 21 over 12. So the top is 21 over 12 all over. Now let's see here. We have 1 minus, let's see, 4, 3. I'm getting 5 ninths. 1 minus 5 ninths would be 4 ninths. I multiplied these two here and I got 5 ninths. And then I take this bottom fraction, flip it, and multiply it times the top, so 9 fourths. And I would get, let's see, 1, 3. I'm getting 21 over 12. I hope I didn't make a mistake somewhere. 21 over 12. Let's look at the back of the book is here, number 41. Yeah, I totally messed that one up. Okay, well, let's see here. I forgot we're in the second quadrant. I apologize. So this would have been negative, and this would have been negative. So I apologize. And let's do this whole thing again. Here we go. And I'm very perturbed at myself. I'm on a roll today, it seems like, which I know is not funny, but here we go. Okay, let's try this again. Okay, tangent of u. Okay, we're in the second quadrant, so tangent of u would be opposite over adjacent. It'd be negative 5 twelfths plus negative 4 thirds, which would give you a negative 21 over 12. Okay, down here we'd have 1 minus, then we'd have a negative 5 twelfths times a negative 4 thirds. And negative times a negative is positive times negative is negative, so 1 minus 5 ninths, I believe, would give us 4 ninths. And so our final answer would be negative, let's see what we have here, 4, it'd be 9 over 4 times 3 goes into this, 3 goes into this. I'm getting negative 63 over 16. And miracle of miracles, that is correct, okay? So I do apologize for the mistake. I hope that makes sense. Remember, we're in the second quadrant, okay? And that's my mistake, but in the second quadrant, the signs go positive, negative, negative, positive, negative, negative. Okay, so tangent is negative in the second quadrant. Okay, number 45. Now I think, let me look in the book here, I think we've changed to different values. Yes, we have. Okay, so here we go. We're in the quadrant 3 now. Sine of u is negative 7 over 25. So sine of u is negative 7 over 25. Okay, this is all given to you in the directions, and then cosine of v is negative 4/5. Negative 4/5, and we're in quadrant 3. Okay, so here we go. Let's draw angle u in quadrant 3. Here's u. We have opposite over hypotenuse. All right, and then over here we have quadrant 3. We have angle v right here, and that would be adjacent over hypotenuse. Using Pythagorean's theorem, we get a 3 right here for that one. Okay. Using Pythagorean's theorem, we get a 24 right here for this side. Okay. All right, here we go. Cosine of u plus v would be cosine, cosine minus sine, sine. So cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. Here we go. Cosine of u. Now we got to remember our signs here. Everything's going to be negative in this quadrant except tangent. Tangent will be positive. And we're not dealing with tangent in this problem here, so we should be fine. So negative, negative, positive. Here we go. Cosine of u would be adjacent over hypotenuse, so negative 24 over 25. Cosine of v would be negative 4/5. Minus sine of u would be negative 7/25. Times sine of v would be opposite over hypotenuse, so negative 3/5. Negative 3/5. And I just checked the book, and all of our work so far is correct. So I'm not going to spend a lot of time doing this for you. This is all calculator work here. Calculator work. If you were to multiply these two fractions, you'd get out a positive fraction. Multiply these two, you get a positive. And then using your calculator, if you subtract those, you should end up with, I'm just trying to save time here, guys. You should end up with 3/5, okay? And this is all calculator work here, okay? All calculator work. So, okay, number 49, secant of u plus v. This will be interesting here. Let's see if we can figure this out, okay? Now, before we get into this too deeply, I'm kind of laughing. I mean, could we not just think about this? I have a question for you. If I asked you to find the secant of 100 degrees, okay, would you not just find the cosine of 100 degrees, correct? And then what you would get out, you would just flip it, okay, correct? Well, let's do the same thing here, guys. Think about this. This is so easy. Look, secant of u plus v is the same thing as the cosine of u plus v. Work the entire thing out. Do all your work. Get out your answer. And then when you're all done, just flip it, okay? Well, look what we just did. We just did cosine of u plus v, okay? So we know the cosine of u plus v, using the exact same values here, is 3/5. So if the cosine of u plus v is 3/5, which is, just flip that and you'll get 5/3, and there we go. So the secant of u plus v is the reciprocal of cosine of u plus v, which is 5/3, okay? Okay, pretty simple on that one. All right, moving on. All right, they want us to, I believe, prove this identity. Let me look at the directions real quick. Yeah, this is pretty simple here, guys. Pretty simple indeed, okay? Here we go. Well, we know that sine of pi plus pi over 6 plus x can be broken down into sine, cosine, plus cosine, sine. So I have sine of pi over 6 cosine of x plus cosine of pi over 6 sine of x equals, so I took this whole left side right here and I broke it down to this. Now, sine of pi over 6, so take a look at it here. Sine of pi over 6 is 1/2, okay? 1/2. So I'm going to put 1/2 cosine x plus, now the cosine of pi over 6 would be square root of 3 over 2. Okay? There. Now I'm doing pretty good. Notice up here they factored out a 1/2. Well, let's pull out a 1/2 and see if we get the exact same thing they have over here. Okay, so here we go. 1/2 times cosine x would be 1/2 cosine x, and 1/2 times square root of 3 sine x would be square root of 3 over 2 sine x. So there we go. Exactly the same, okay? Exactly the same. Okay, moving on to 57. The directions for 57 say to, hold on one second here, let me turn the page in my book. The directions for 57 say to simplify and, let's see. So to simplify, so we're going to simplify our answer. So here we go. Should not be too difficult to do. And here we go. So we have cosine of two angles that are being subtracted. And so that would be cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine. And here we go, cosine of u, that would be cosine square root of 3 over 2, which is 270 degrees. Cosine of v is cosine of x plus Sine of u is sine 270, and then sine of v would be sine of x, because this is u right here, and this is v right here, okay? Now, okay, students, so here we go. The cosine of 270 would be 0. So 0 times cosine is just a big 0. Sine of 270 would be negative 1. So I have negative 1 times sine x. Okay? Now, 0 plus negative 1 sine x would just be negative sine x. And then if you'll look in your trig identities, that's it, actually. That's as far as we can go. That's as far as we can go right there. So negative sine x, okay, would be your answer. All right. So there we go. We simplified. Moving on to number 61. Number 61, the directions say to verify the identity. Okay, this will be a little bit of work. It's kind of like a busy work, but it's not too bad, okay? When you're adding two angles, it's cosine, cosine minus sine, sine. So we really have, for this whole expression right here, we're going to put cosine, cosine, cosine minus sine, sine. Okay, that whole group there. And now we have this here. We're going to make a substitution right here. And we're going to put cosine, cosine plus sine, sine. Now, students, please listen to me and learn to make shortcuts. Okay, listen to this very carefully. Now, please watch this, okay? Look, think back to Algebra 2 when you had x minus 1, x plus 1. Watch this, please. X times x is x squared. X times 1 is x. Negative 1 times x is negative x. And negative 1 times 1 is negative 1. Your middle two terms canceled out, and you're left with x squared minus 1. Whenever this term here is identical to this term here, and this term here is the exact opposite of this term here, you can save yourself some time and just take the first term times the first term and last term times the last term and get this. So notice what we have up here. We have that pattern. We have a first term here identical to this term over here, and we have this term here is the exact opposite. That means their signs are different. The exact opposite of this over here. So all we have to do is take first term times first term and take last term times last term, and we're good. Okay, so this shouldn't be too difficult. So here we go. Cosine xy, cosine x, cosine y times itself would be cosine squared x, cosine squared y minus, and now last term times last term would be sine squared x, sine squared y. Okay, so I want this whole side here to equal this over here. Now, I'm not sure how to do this, but I know we can make some substitutions. For example, look at this, students, please watch. I notice that nowhere on this side over here do I have a cosine y. So I probably don't want this cosine y, so instead, I'm going to put this. Think of your Pythagorean identities. For cosine squared y, I can put 1 minus sine squared y, okay, then minus. Now look, nowhere do I have on this right side over here sine x. So I don't want this sine x. I'm going to put 1 minus cosine squared x. And then sine squared y. Now let's simplify. Take your cosine and multiply it through. You'd have cosine squared x minus, and I hope this works. It might not work. Cosine squared x minus I might end up having to start over. I should have done this first. Now let's take this and multiply it through, but remember, you've got to change your signs as a negative sign here, okay? So sine squared times 1 is positive, but it's a negative, so negative sine squared y. Sine squared times negative cosine is negative, but there's a negative here, so positive sine squared y cosine squared x. Okay, now hopefully that helps. Look at this. This term here is cosine squared x, sine squared y, which is the same thing as this term over here. And one's positive and one's negative, so I think it worked out perfect, which I'm very glad, because I'm starting to worry about that. This term here totally cancels with this term here. And thankfully, thankfully, we're good. So, here we go. And that definitely equals, not sure what just happened, but anyways, cosine squared x minus sine squared x equals this over here, okay? So we're totally good. All right, number 65. Now this one's interesting. I want to say one thing to you guys. Remember, anytime you have an arc sine or an arc cosine, that really means an angle. You're just rewriting an angle. So you really do have an angle right here, okay? So this is going to be our angle U. This is going to be our angle V. Don't forget that. Look, just like a logarithm. Let's see, how do we do that real quick here? In algebra 2, we say what? It's been a while. If we have A equals B to the C, that's the same thing as the logarithm. Base B of A equals C. Remember how a logarithm from algebra 2 is the exact same way to rewrite an exponential like this? Well, an arc sine or an arc tangent or an arc cosine, whenever you have the word arc, that's another way of writing an angle. You're just rewriting an angle, okay? So arc sine really represents an angle, and so does the arc cosine. It represents an angle, okay? Now the directions say for number 65 too, rewrite it as an algebra expression. So here we go. Let's see how we do here, okay? Probably more than likely it's going to be really wise to do this first real quick. Arc sine of x would be, let's see here. Draw my triangle here. And I would have, let's see, the sine of an angle equals x over 1. So let's call it theta. So sine of x here would be, this is the same thing as saying sine of theta equals x. Okay, you're looking for an angle. So sine of theta would be x over 1. Okay. And then also they're saying here, this would be cosine of an angle equals x, okay? So cosine of theta right here would be adjacent over 1. Now if you use Pythagorean's theorem, you're going to get the square root of 1 minus x squared for this side. And if you use Pythagorean's theorem, you get the same thing here for this side. You'll get the square root of 1 minus x squared for this side here, okay? All right, with that in mind, let's continue on. Here we go. Now, remember, look at this like it's your u, look at this like it's your v. You have sine of u plus v. Now, the sine of u plus v is sine cosine plus cosine sine. So we have sine of u cosine of v plus cosine of u sine of v. Okay, now let's be really careful as we figure this out. Okay, watch this carefully. Okay, now students, look at this carefully. There's nothing wrong with putting theta here and theta here. Okay, nothing wrong with that. But remember, I did say that arc sine was really like angle u, so it'd probably help us if we call this u. And here I did say that we were going to pretend this was angle v. So really, we should call this angle here v. Okay, now here we go. sine of u would be opposite of hypotenuse, which would be x, okay? Cosine of v would be adjacent of hypotenuse, which is x, plus cosine of u. Now, cosine of u would be adjacent over hypotenuse, so it would be square root of 1 minus x squared. Now, sine of v would be opposite over hypotenuse, so it would be square root of 1 minus x squared. Okay, now, let's simplify. X times x is x squared. Plus, now remember, anytime you multiply an exact square root times an exact square root, you get what's on the inside, okay? So, square root of 1 minus x squared times square root of 1 minus x squared is 1 minus x squared. There we go. Now look at this. X squared minus x squared equals 1. And that is the answer. The answer is 1. So there's your algebra expression, 1. Okay, kind of funny. All right, 69. Okay, we're going to solve this equation. Okay, we're going to solve this equation. And let's go ahead and see if we can do that. We have sine of two angles being added together. And that would be, of course, sine, cosine, cosine, sine. So we have sine of x, cosine of 60 degrees, plus cosine of x, cosine or sine of 60 degrees, okay? So I substituted this out for this here, this whole expression right here. All right, now, make a substitution for this here. So sine, when you're subtracting two angles, it'd be sine, cosine, minus cosine, sine. So, plus, then we have sine, cosine, minus cosine, sine equals 1, okay? Now, let's pull this up here real quick. Okay, now for cosine of 60, we have 1/2, so here I'll put 1/2. And for sine of 60, I would have square root of 3 over 2, okay? There we go. Now, okay, let's see, bring down your sine x, plus bring down your cosine x, plus bring down your sine x, minus bring down your cosine x, equals 1. Now, hopefully some terms will cancel out here, I hope. Yes, right here. Cosine x square root of 3 over 2 minus cosine x square root of 3 over 2. So, they're gone. And I'm left with sine x times 1/2, which would really be 1/2 sine x plus 1/2 sine x equals 1. Okay? Now, obviously, 1/2 plus 1/2 would be, hold on one second here, make sure I've not made a mistake anywhere. Okay, everything looks good. So I have 1/2 sine x plus 1/2 sine x. It's like adding like terms. 1/2 plus 1/2 is 1. Sine x equals 1. Of course, 1 times sine x would just be sine x equals 1. So when I think they give us a domain on this one. Yes, they do. It has to be between 0 and 2 pi. So when does sine give you 1? When you take the sine of an angle, let's see. It's obviously going to be one of our quadrant angles, so sine of 0 does not work. Sine of 90 does work. Sine of 180 does not work. And sine of 270 gives you a -1. So the answer is 90 degrees or pi over 2. Okay, pretty good problem actually. Two left. We're finally done. Okay, all right, let's solve this equation right here. Number 73. Okay, so here we go. This will be a tough one. We can do this. All right, we have we have tangent of two angles being added, and so what we're going to have would be tangent plus tangent. So we have tangent x plus tangent of, I'm going to go and put 180 for pi, over 1 minus tangent of x tangent of 180, okay, plus 2 times, then we have sine of two angles being added, okay? That'd be sine cosine plus cosine sine. So sine x cosine of 180 plus cosine of x sine of 180 equals 0. Okay, so here we go. Well, first of all, let's find out what the tangent of 180 is. Real quick here. That's a quadrant angle. It's going to give you 0, so let's write it up here. The tangent of 180 is 0, and the cosine of 180 would be negative 1. And the sine of 180 would be 0. Okay? So here we go. Tangent of x plus tangent of 180, the whole thing is 0. So tangent plus 0 would be tangent over. Now here we have tangent x times 0. And anything times 0 is 0. We have 1 minus 0, which is a 1. So we really have tangent x over 1, which is just tangent x, okay? So that simplified pretty nicely, actually, to be honest with you. Now, let's see what we have over here. Cosine of 180 would be negative 1. So I have 2 times negative sine x, because this is negative 1, and sine times negative 1 is negative sine x, plus, now I have sine of 180 is 0, and so this whole thing is 0. Cosine times 0 is 0, so I have sine x plus 0, which is really just negative sine x. So there we go. So I have tangent x, and then 2 times negative sine would be negative 2 sine x equals 0. Now if you need to pause the video and copy that down, feel free to. I'm going to go and erase this to give some more room to work with. But actually what we have now is a trig equation. We've done these before. It's going to take a little bit of work. Remember, when you have two different functions, you have to either substitute one of them out or try to factor. Well, factoring is not going to work. But what I could do is this. For tangent, I could put sine over cosine. That might work. And then minus 2 sine x cosine x over cosine x. Now what I did is I multiplied this whole thing here. I put it over 1. I multiplied the top and the bottom by cosine of x to give me a common denominator. I'm just trying something here, okay? See if it works. Okay, now what I have is sine minus 2 sine x cosine x all over cosine x. Now, that's pretty helpful. Look what I can do now. I can multiply both sides by cosine. I can multiply this side by cosine to get rid of my fraction. Multiply this side by cosine. And 0 times anything is just 0, so I'm left with 0 equals sine minus 2 sine x cosine x. It's a lot of work, but we're doing really well, okay? We're doing really well. Now we're making a lot of progress. Now, you say, well, Mr. Earhart, we still have a problem. We still have a sine and a cosine. True. But now I can factor out a sine. And when I do, I'm left with 1 minus 2 cosine x. So now I have two groups. I can set equal to 0, and each group only has one trig function. So my first group will be sine x equals 0. My other group will be 1 minus 2 cosine x equals 0. Okay, now let's see what my answers would be here. When do I get 0? When I take the sine of it. And let's see, I have sine of 0 just works. Sine of 90 does not. Sine of 180 does not. And actually sine of 180 does work. So far x equals 0 and 180. Okay, or we call it 0 and pi. And the sine of 270 does not work, so we're good there. Now let's come over here. We would have, look, cosine of x equals, bring your 1 over, make it a -1, then divide by a -2, you get a positive 1/2. So when does cosine give us a positive 1/2? Well, I'm glad that you asked. Let's take a look and see. Cosine gives us 1/2 at 60 degrees, okay? So I want to use the two quadrants. I want to use the two quadrants where sine is positive, and sine is positive here, and sine is positive here. So I'll put a 60 here and a 60 here. So what answer would be 60 or pi over 3? And the other answer would be all the way around 300 degrees, or 1 2/3 pi, which would be 5 pi over 3. Now, a word to the wise, a little bit of a warning. Okay, remember I told you guys, anytime you multiply both sides of an equation by an unknown, remember earlier we multiplied both sides by cosine x, sometimes you get extra solutions that don't work. Also, your original problem had a tangent and a sine in it, so some of these answers, 1, 2, 3, 4, might not work. Now, I know it takes a little bit of time. You have to take each one and check each one individually, okay? And if you'll do that and check each one individually, I believe all of them work. I'm looking now in the answer key, and yes, they do. All of them do work. So in this case, we're good. All 4 of these answers do work, and so there is the answer to number 73. Okay, not too bad. That's kind of funny how we end the homework assignment. Number 77 is probably the easiest problem in the entire homework assignment. And usually homework gets a little more difficult as you go. All they wanted you to do here was just simplify. So it's pretty simple. Sine, you're adding 2 angles. So sine, cosine plus cosine, sine. So sine, cosine plus cosine, sine. That's it. You're done. I will explain quickly what this triangle means. It's called delta. And what it stands for, it means the change. So in other words, we're saying sine of theta plus the change in theta, like if there's the difference between 2 angles, or whatever the change in theta might be. Well, I'm sorry, excuse me. We'll get into that later, students. Trust me, okay? We'll get into later what that means. But that's what the symbol is, delta. It means change. That's all they wanted you to do. So, okay. All right, guys. I hope this homework help video, as bad as my voice has been, I hope it's been a help to you. If you have any questions, don't hesitate to call or email.